Hello to everyone. I hope you're all doing fine. Today, I'll walk you through the new features of the latest Aimsun Next version. So recently, we've seen large datasets related to human movements that are published and they can be purchased or offered as open source data. These data usually are obtained from GPS devices, cell phones, drones, and so on. All this fact contributes to further develop or explore the individual mobility, which is related to the usage of various transportation modes. I believe that we need to rethink about the existing inventory of all the available assessment tools that we currently have in mobility. Basically, we're shifting from the traditional modeling methods, which is modeling four-wheel vehicles that go from point A to point B, and we start thinking about how to model the movement of people as individuals. Individuals that walk, cycle, make use of the public transportation, and also combine different modes of transportation. This so-called intermodality should be also reflected and assessed by the traffic modeling tools. Well, this is exactly the philosophy of the Aimsun Next 20, quite different from the previous versions where we were dealing with the four-wheel conventional vehicles such as cars, trucks, taxis, buses that go from zone A to zone B. Now our target is to model people, to model individuals that go from origin A, which can be even their home address, to the destination B, by choosing the mode of transport that fits better to their trip purpose or destination. However, I have to admit that we are not fully there yet, but we will work our way up with focus on modeling individuals and multimodal mobility. So by launching the Aimsun Next 20, the journey has just started towards that goal. We are introducing how bicycles and motorbikes move and interact with the traffic in urban and interurban roads. A new specific behavioral model for bicycles and motorbikes, which is only available in the microscopic simulation. This new car following model can model the lateral and longitudinal movement of vehicles that don't follow the lane markings. Bicycles and motorbikes perceive the road surface as a bidimensional space compared to the four-wheel vehicles that perceive it as a monodimensional. Let me better explain this. The four-wheel vehicles occupy the entire width of its lane, and motorbikes and bicycles may drive side by side, filtering through a queue of four-wheel vehicles, as well as they can overtake the four-wheel vehicles and also stop in advanced stops at where we have signalized intersections. How to activate this feature in Aimsun Next 20? It can be activated by vehicle type, either for the four-wheel or the two-wheel vehicle types, and or by section object. For example, it can be activated only for motorbikes to reflect travel behavior, as it is in most of the European cities, whereas the activation of the model for all the vehicle types could be more suitable for Eastern countries where lane discipline does not exist. To sum up, two-wheel vehicles such as rickshaws, tuk-tuk, motorbikes, bicycles, and four-wheel vehicles such as cars, trucks, and buses can share the road space and modeled properly. Another, in my opinion, the top feature is the introduction of the new in-house pedestrian simulator. Its objective is to enhance this multi-platform, this integrated Aimsun Next software, in order to extend the range of modeling applications within the micro simulation. However, our new pedestrian simulator does not aim to replace the Legion for Aimsun, at least the light or expert version. The two simulators are now complementary and they can serve different use cases. What is the reason that someone needs to switch from the Aimsun for Legion to Aimsun Next Pedestrian Simulator? It's faster, as the code is embedded in the Aimsun Next software. It has a limited number of pedestrians. It offers a deep integration and multi-platform support, and it's easy of use. It's much faster in editing, and there is no need to create objects that pedestrians can walk. It uses the Aimsun Next buildings and polygon obstacles, and pedestrians can automatically recognize those objects as non-accessible space. So when we import, for example, OpenStreetMaps, these can be perceived as objects by the pedestrians. Before, with Legion for Aimsun, our users could purchase the license and model the movement of pedestrians on sidewalks, the interaction between pedestrians and traffic at crosswalks. For example, they were calling a face with a push button detection and the boarding and alighting process at public transport stops. Now, these use cases can be modeled with our new pedestrian simulator. Legion for Aimsun is not obsolete. It targets for pedestrian engineers working with Open Building Station Designer and Legion Simulator. If someone is using Legion for Aimsun to create service points in order to, for example, evaluate queues or see the pedestrian congestion in queues at specific service points, export statistics, he should remain a Legion for Aimsun user, as the new Aimsun Next pedestrian simulator does not support these functionalities. No separate license is needed, plus the idea of building our pedestrian simulator, in fact, allow us to offer deep integration with other mobility options. In this case, to develop, for example, the following feature, which is the dynamic public transport assignment feature. So another important feature of the Aimsun Next 20 is the introduction of the dynamic public transport assignment in microsimulation, which refers to the pedestrian capability to choose to either walk to the destination or walk first to the public transport stop, wait for the public transport, board, travel, drop off, take another public transport line, or walk to the final destination. The dynamic public transport assignment allows pedestrian and public transport to interact. Basically gives pedestrians the option to take public transport to reach their destination instead of just walking from A to B. With Legion for Aimsun, it was offered the choice for pedestrians to reach a bus stop as a destination, and in the OD matrix, the option to define a certain number of pedestrians that alight from that location to a bus and then define a distribution about destinations. We're not talking about this. We're talking about moving people as individuals. A pedestrian who go from the in A, for example, to the out B will walk from the in A to the bus stop, will board in the bus, will drop off at the next bus stop, and the same pedestrian agent will walk from the bus stop to the out B, which is his final destination. As I said already, pedestrians will have the choice of various transport modes. At the moment, they can choose to either walk or board in a public transport vehicle, or even combine those transportation modes. And this is just the beginning. What you see here is just one of the seeds that we have planted and has grown. You can also use this feature to build more comprehensive pedestrian models, or even to calculate dynamic schemes for public transport that can be fed back to the distribution and modal split stages of the 4-step modeling. Let's have a look now at the model of the city of Malaga to see these functionalities. I have launched a simulation with pedestrians walking throughout the network, sidewalks, crossing streets, then waiting at signal stops to cross, board and alight a public transportation vehicle. That's a great functionality. I'll click on a pedestrian agent and choose the tab named Trip. This informs us about the entire path calculated for this individual using public transportation and or walking. In this case, we see that this pedestrian starts from the origin point, which is the pedestrian entrance, goes to destination, which is a public transport stop. Then he will board to a public transportation vehicle. He will reach his destination. He will combine another public transportation line. He will drop off to the next stop, and then he will walk to the final destination. Let me launch the simulation to see the whole path of the pedestrian. He will cross the streets. He will reach the public transportation stop. A public transport vehicle will arrive. They will continue their trip. We can see that the public transport line goes straight ahead until here. He will drop off here. He will take the other bus that comes from this point. Finally, he will reach the final public transport stop, and he will walk to the final destination. That's amazing, because now we can model pedestrian agents as individuals. We can gather statistics. We can offer to the user the modal split option. As we've seen in our example, when a bus arrives to a public transport stop, we can now see how many passengers are already on board and how many passengers board from this stop. So we have put together the mode choice for individuals to either walk and or use the public transportation system. How can we check results of this calculation? I will fast forward the simulation. In the meanwhile, I would like to mention that this mode choice is based on comparing the generalized cost of walking to the destination with the generalized cost of walking to a public transport stop, waiting, paying a fare, traveling on board, making transfers, and walking from the last stop to the destination. The simulation has finished, and in the replication window, I can see another tab that has been generated. It's named Dynamic Public Transport Trips. I can press here and see per OD, per origin destination, the number of pedestrians that have been generated and arrived to the destination. Also, I can have an overview of the costs of these paths. I can press the output matrices to export the scheme matrices of all these cost variables. The scheme matrices will be created under the folder OD matrices, scheme matrices that include waiting time, walking distance from zone to zone, etc. And these can be used in the distribution and mode split steps in the travel demand modeling. I can assure you that this integration of the Aimsun Next 20, combining pedestrian simulator with the dynamic public transport assignment, is one of its kind in the market of the transportation modeling software. Next major feature is the hybrid macro-meso simulator that allows the user to extend the scope of a mesoscopic model so that he can also capture the rerouting that is happening outside of the study area when, for instance, new traffic management strategies are applied. With respect to this feature, I can distinguish two main use cases. First, it covers the need to build larger models without having to extend the meso model. This automatically means less computational and calibration efforts on the dynamic side, but we can still use the macro model, which is simplified in terms of geometry and path calculation. Second, we can reduce the size of the existing meso model to meet the performance simulation metrics. This means that we will focus only to the study area, but without excluding the rerouting phenomenon. One example. Let's say that the study area includes the city center where all the mitigation strategies will be implemented. These strategies will have an impact on the demand that is generated from some zones to some other zones. So by building only a meso model with respect to the city center, we will be missing the impact of these strategies to the traffic demand generated out of the study area. The macro part is not the same as the static macro assignment because individual vehicles are generated. The only static part in the macro part is the way that the travel times are computed. Travel time is computed by summing up the volume delay functions, turn penalty functions, and junction delay functions. In the mesoscopic part, travel time is calculated based on the dynamic cost function considering the impact of the various models such as car following, lane changing, gap acceptance models. In the mesoscopic part, travel time is calculated based on the dynamic cost function considering the impact of the various models such as car following, lane changing, gap acceptance models. And something that we need to clarify at this point is that we are moving individual vehicles for both levels, macroscopic and mesoscopic. Another appealing feature for more advanced users is the introduction of the new path assignment plan object. This feature allows the user to combine multiple path assignments that can be either static paths, which are not time dependent. This means that the same paths for the entire assignment period are calculated and can be used later on, or dynamic paths, which are time dependent, which means that they calculate a set of routes per OD per interval, something that is defined on the route choice cycle in the dynamic traffic assignment. Thus, the user will be able to assign an initial time and duration to each path item and combine paths during a dynamic simulation. Another interesting feature refers to the actions to change turn and section parameters which have been developed to support mainly long, micro, meso, or hybrid simulation scenarios. The user will be able to control the behavior parameters at section or turn level in case the traffic conditions change. For example, the user can select different criteria to set parameters for the look ahead or lane changing cooperation during the simulation under congested or uncongested conditions. Now, a feature related to the four-step modeling, we introduced loops and scripts in four-step experiments. This is basically a feature for travel demand modeling users. As you can see in the slide, now we have moved forward and the user can add a new loop controller to the four-step experiment diagram. And once the user has computed the costs from assignments and he wants to feed these costs back to the distribution or model split procedures until he reaches the stopping criteria, he will be able to do so. Thus, the process will result with different demand and costs. All this process before was done manually. Now, by using the loop controller, this can be launched automatically. Not forget to mention that we have also introduced boxes that the user can set for customized calculations via scripts. We have also added some additional stopping criteria for the DOE. These criteria are related to the stability of the equilibrium solution. Now, the user can stop the iterations when the relative gap is below the defined threshold for a given number of consecutive iterations. In addition, you can stop the iterative process when the change in flow and/or the cost between iterations is below a defined threshold for at least a given percentage of all sections. We also took care of the static OD demand adjustment. We redefined the stopping criteria. Now, the static OD adjustment can stop the iterations when the linear regression between assigned volumes and counts reaches a target of R squared and the target slope. Previously, the number of adjustment iterations was fixed and predefined. This feature would allow the user to define on his own the expectations of the final result. In this slide, which is not the final slide, you can see that there are more features included in the Aimsun Next 20 than the ones I previously mentioned, such as the automatic management of project files. Now Aimsun Next offers to the user automatically to arrange the files in a structure, in a fixed folder structure to facilitate the creation of backups and deliveries. We have also updated the embedded Python version for the scripts to Python 3. However, we maintain an installer with the Python 2 version so that the users can make use of the scripts already coded with older Aimsun Next versions. Now let's switch to the new Aimsun Next license type, the Aimsun Next Viewer. Let's first see what the Aimsun Next Viewer stands for. The viewer is a new tool for a remote third party to replay a recorded simulation or retrieve data from a previous execution of any Aimsun Next model. The viewer is for people involved in a project who need to review model outputs remotely but do not have access to the Aimsun Next software. I can see two main use cases for consultants. First, to generate an Aimsun Next viewer license and send it to the client or any other third-party user so that he can review the simulation model input parameters and the simulation results. The second one is to generate an Aimsun Next viewer license and use it for internal presentations without making use of the Aimsun Next full license, while, for example, other colleagues in the department can take advantage of it and keep on working. The main advantages is that you can open an ANG file, retrieve results from a database, four-step model result files, path assignment files, and real data sets, and play a recorded simulation. No computational capabilities are available. No model editing is allowed. We cannot create any object in the ANG file. No saving options are available. It is just an Aimsun Next viewer. How do I get the viewer? You can visit our webpage where you will find two different contact forms to submit. One form with your data and another form for the person who needs the viewer. Once done, we'll send the installation guide for a quick and easy setup in just 2 steps to both of you. There is no limit in registration for the viewer. You can apply for as many licenses as you like, for as many different people as you like. Any transport modeler who is an owner of an Aimsun Next license with active subscription will be able to generate a viewer license and share with the client his work. Once it's installed, the viewer license will be valid for the next 3 months from the date of installation. You can only install the viewer on one authorized computer running Windows, Linux, or Mac. Please note that the viewer software is not a portable software. You can check our webpage for more information on the Aimsun Next new features and access the viewer webinar to explore its functionalities.